Hi friends, welcome to GMP tutorials. So today we are going to discussing about the image processing part. Okay. So in the previous video we are discussing what is meant by image, how we are going to use the image in the real-time applications. Okay. Let's move on to today's topic is nothing but image sampling and quantization. First of all, what is meant by image? Image is a two-dimensional function where it consisting of some amplitude or maybe intensity with respect to the corresponding spatial coordinates in case of the continuous domain, right? So what is the need of the sampling and quantizations in the image processing application? Let's move on to the next one. So suppose if you want to capture the image, there is a different sources are there, like if you are taking the images with respect to the sensors, maybe camera, whatever it is. So at that time, these are all the devices are maybe continuous domain, right? So that data given by the corresponding sensing devices are in the form of a continuous. So it consisting of some amplitude as well as it is also having some related time, so that can be represented in the time format or spatial relations also. So if you want to create a digital image from the continuous image, you have to follow the two basic scenarios. That is nothing but sampling and quantizations are the two techniques that are used in our series. Okay, so this is a sampling and quantization. So these are the different sources for taking the data from the corresponding images. So that maybe images is nothing but consisting of some amplitude as well as the spatial behavior of the corresponding sense. So what happens is that if you want to convert this continuous image into digital image means that obviously you have to follow the two methodologies. That is nothing but sampling is the one technique and second one is the quantization. Okay, let's move on to the next one. So basically, basic concept in case of the sampling is nothing but just the sampling means just dividing the information. Suppose if you are having a continuous information, that information can be divided into the form of pieces actually. So let's for that purpose, I will take this some. So basically, image is a continuous image that can be represented as if you want to convert that image into the digital domain, obviously you have to if you want to simply say that if you are dividing the corresponding images in the two formats, one is nothing but in terms of amplitude and second one is nothing but in terms of the time domain also. So just digitizing the sample function in both directions, that means as well as in the continuous domain as well as in terms of the amplitude as well as in terms of the time also. Just simply we can say that dividing the time axis is generally called as a sampling. So suppose if you are taking the it is a one kind of a signal. If you are assuming like this is a continuous time signal. This continuous time signal is dividing in the time axis with some time intervals. This is generally called as a sampling. At the same time, dividing the amplitude axis is generally called as a quantization. Okay, that is a basic difference actually. So digitizing the coordinate values is called as a sampling. Digitizing the amplitude value is called as a quantization. So this is nothing. This part is generally called as a sampling related. Dividing the amplitude is nothing but a quantization. This is a basic difference between sampling and quantization. Okay, so let's move on to the next one. So the samples are shown in the small dark squares are superimposed on the signals. Okay, superimposed on the function, that is nothing but spatial locations are indicated by the corresponding tick marks in the bottom. So that means if you are performing the sampling means obviously just let us move on to the next one. So let us take it as a so this is actually it is a continuous function. It is nothing but where A to B is nothing but a scanning line showing the intensity variations along the A comma B. At the same time, this is nothing but the corresponding value that is nothing but showed by the corresponding information, that is nothing but B is nothing but a scan line showing intensity. That means whenever this scan line shows the corresponding values, the corresponding intensity values can be represented in this graph actually. So let us observe this one. This part is nothing but actually this complete information is nothing but white information. So for that purpose, this white can be represented as with a high value. So A to B is nothing but this part is generally consisting of some information, that is nothing but this is related to this place only. So this place consisting of some black, right? So at the same time, so in between these two gaps, this gap and this gap is also consisting of some white intensity value. That white intensity values can be represented with a high value. Generally in case of the grayscale image, we are representing the value with 255, right? 255 is nothing but highest value in case of the grayscale. 0 is nothing but lowest value in the grayscale. So for that purpose, the difference between this line to this part is nothing but consisting of a high value. That's why it is consisting of a high intensity. In between this place is nothing but this, within the range, the corresponding values are very high in this region and this is also very less. So based on this one, the curve is showing like this. Obviously there is a question mark, sir, why this kind of the glitches are present in this one? This is nothing but because of the noise. Because of the noise content, it can be represented like this. Moreover, if you are observing this one, in this case, there is a small circle is there, that small sampling and quantization in the quantization. So that means this bottom tick mark represents the corresponding time axis with dividing the some slices. So that means this bottom mark is also used to represent the corresponding reference point, where the corresponding circles is there, that is nothing but superimposed on the corresponding location. That means if you are dividing the corresponding amplitude axis means, these are the points, like the blue color rectangular shape is there, that can generally called as a corresponding location. As well as this is nothing but sampling in the time domain. At the same time, you have to perform the corresponding values in the time domain also. So sorry, amplitude domain. So for that purpose, this part is generally called quantization. Quantization means dividing the time axis, dividing the amplitude. So this complete value can be divided into 8 values actually. This topmost value is nothing but 255 and bottommost value is equal to around 0. So whenever the corresponding pixel values are matches to this corresponding reference value, that can be represented in this direction. So finally we are getting like this. So if you are quantizing the corresponding, so here this is this bottom line tick mark reference to the corresponding points where we are taking the corresponding amplitude values with respect to the corresponding time instance. So this is just how we are going to convert the sampling continuous image into digital image. So if you are projecting the same information in the digital plane, we will appearing in the we will see in the next slide. So this is nothing but just whatever we are explained in the previous slide. So that related information is also there. So here just I will revise very quickly. So the set of dark squares consisting of a sample function. However, the values of the sample still is a continuous range of values of the intensity. In order to form a digital function, the intensity values also must be converted in the discrete value. So that means obviously if you are getting the sampling point of view, if you are getting 1.2, this 1.2 is not possible to represent in case of the digital domain. So for that purpose, you have to round off that value to either 1 only. So that is the way you are going to performing the quantization also. As well as the vertical tick marks indicate the specific value assigned to the 8 intensity level. This is nothing but related to corresponding amplitude axis. It consisting of the 8 values, 0 to, and highest value is nothing but 250, that can be represented as a white color actually. At the same time, the vertical in case of the dividing the 8, that is the vertical bar in case of the corresponding is also nothing but intensity values, as well as the second one is nothing but related to time axis also. This is just related information to the previous, already we have explained that one also. So this is a way how we are going to represent this. This is nothing but a continuous image actually. So this is nothing but a continuous image, continuous time image. So this is nothing but a digital image. Okay. So here nothing but result of sampling and quantization we are getting like this. Why? Because if you are performing in that manner, obviously we are getting some samples of value. That samples of values can be mapped into the digital plane. It is appearing in this way. So however, the spatial sampling is accomplished by selecting the number of individual mechanical increments at which we activate the sensor to collect them. That means instead of taking the all values of the corresponding range, just we are taking some part of the values. So based on that one, we can represent the corresponding values in terms of some numerical data, so that will project the corresponding same information in the image plane itself also. As well as mechanical motion can be very exact, so the principle there is almost no limit on how fine we can sample an image using this approach. In practice, limits on sampling accuracy are determined by the other factors such as the quality of the optical. So at the same time, the sampling is nothing but it is also, we are not getting the 100% output if you are not having such a kind of a good quality of the optical components while capturing the corresponding system is also. So this is related to just a brief introduction about what is meant by sampling. Just I will explain very Telugu in a few minutes. సో బేసిక్గా మన దగ్గర ఉన్నటువంటి ఇన్ఫర్మేషన్ కానీ వాట్ ఎవర్ వీఆర్ క్యాప్చరింగ్ రియల్ టైమ్లో తీసుకునేది అంతా ఒక ఇమేజ్. ఆ ఇమేజ్ అనేది ఒక కంటిన్యూస్ ఇమేజ్లో ఉంటుంది. ఆ కంటిన్యూస్ ఇమేజ్ని మనం ప్రాసెస్ చేయాలంటే యూజ్ చేసే డివైజెస్ అన్ని డిజిటల్ devices. So that is digital devices can understand only digital information. So for that purpose, this continuous image is also converted in the form of a digital information. So దానికి ఏం చేయాలంటే బేసిక్గా we are taking the corresponding input image into టూ ప్రాసెస్లో కన్వర్ట్ చేస్తాం. ఒకటి టైం యాక్సిస్ని డివైడ్ చేస్తే దాన్ని శాంప్లింగ్ అని చెప్తాం. క్వాంటైజేషన్ అంటే ఆంప్లిట్యూడ్ యాక్సిస్ని డివైడ్ చేస్తే దాన్ని క్వాంటైజేషన్ అని చెప్తాం. సో దట్ ఈస్ ద బేసిక్ సినారియో ఇక్కడ మనం చేసేది. సో అదే ఫార్మేట్లో so just we are taking some input values here. That input values is nothing but just it is a continuous image. This continuous image is A to B is one scan line is there. With respect to corresponding scan line, ఇక్కడ మనకి amplitude values వస్తాయి. ఈ గ్యాప్ ఏంటంటే యాక్చువల్లీ ఇక్కడికున్న గ్యాప్ వైట్ కలర్. సో దట్స్ వై ఇది హైయెస్ట్ వాల్యూస్ ఇక్కడ. at the same time these two places. This middle part is related to the corresponding values whatever it is present in the corresponding line లో ఉన్నాయి. సో దిస్ ఈజ్ నథింగ్ బట్ జనరల్లీ క్వాంటైజేషన్ వాల్యూస్. దిస్ ఈజ్ నథింగ్ బట్ sampling values. Okay, this is the related values after getting the corresponding digital values. So that is nothing but after projecting the same information we are getting like this. Okay, so this is related to the sampling and quantization point of view. Okay, thank you guys, thank you for your support. So please watch the videos till the end of the video, so it will give a very motivation for me also. So thank you guys, thank you for understanding. Thank you.